In this lesson, we're going to see a lot of triangle stuff, specifically with angles. So, when we look at a triangle, and the angle specifically, if we look at these three angles, and at these, then all three angles always have to add up to 180, right? And so, the sum of the angles for all triangles is 180. If we said, well, this is what you'll see is something like x, maybe this one is a 2x, and then maybe this one is an 8x. So to find x first, you would have to add all three of these, x, 2x, and 8x. And if you add these together, then you would get 180 degrees. And from here, you just have an equation that you need to be able to solve, which we will see a lot of. This right here would be considered a 1x. So these are the first page of the notes. That was just a quick review. In Chapter 5, we worked with angle measures and triangles. We've seen some of that. Now we're going to practice writing equations, which we have done for missing angle measures. Recall from Chapter 5 that the angles of a triangle sum to 180. That's what we just talked about. So when we see this triangle right here, we know that all three of these will equal 180. So to figure out what that missing angle is right here, we just need to subtract 120 and then the other angle, 24, and that would tell us this x value angle measure. So that is 36 degrees. Now over here on the left, yep, they've got what this would look like as an equation right here. And then just solving the equation would give us the solution, x equals 36 degrees, which we found already. This one is a little different because we need to figure out first what this angle measure is. You're going to see a lot of this kind of stuff on the homework, okay? So we're going to take our 180, but that would be all three angles. Let's get rid of this 42 right here, and also the 64. Some of you guys are going to want to add those together and then subtract, and that is okay. 74 degrees. So this angle, this one is 74 degrees. But if it asks us, and that may be one of the answers, the actual angle measure, but then it may ask us to solve for x. So we would say that the 74 degrees is equal to 2x. And then solving for x, we would divide both sides by 2, and we get 37. Now we don't label this with degrees because x is not in degrees, it's just part of that angle measure. They did show that over here on the left as well. So this would be the equation, which we will look at. We're going to make some of these types of equations, but only when we have more x's involved. Otherwise, I'm probably just going to do it like we did over here on the right. And the solution is just solving the equation. So same answer. X is 37. And we got the 74 right here, which was the measure of that angle. This means, right here, if I took the red here, the 42, the 64 in purple, and the 74 in green, if I added those three, I would get the 180, which is what it needs to be. So we look at these types and we kind of struggle because they've only given us one angle, or we think that they've given us one angle. As it turns out, they've given us two. This angle right here, since it's got that box, it's 90 degrees right here. So these two angles combined, right, and I'm doing this a little bit different than we did those last couple. These two combine to be 110 degrees. Well, that gives me two of the three angles. So if I wanted to solve for x, I got to take 180 and subtract the 110 from the two angles, which would be 70 degrees. So x is 70 degrees. So just to check, by the way, and that's what I'm doing right here, is if I got that 90 degree angle, the 20 degree angle, and then the 70-degree angle. If I add these, what should I get?
180.
Should get 180, which I do. Now again, that's because all three angles in the triangle need to add up to 180. So that checks off.
I just don't get the symbols.
Number 2, we'll get there. On this one, let's do this one a little bit different like we did those 2 examples. So the 3 angles need to add up to 180. So I'm going to subtract this 38 degrees and also this 71 degrees. And whatever I get after I subtract would be the measure of this angle radical. Now we could just use a calculator, right? 180 minus 38 minus 71. It would tell us. And the answer radical is 71 degrees. All right, so yeah, let's figure out what that actual angle is, which will then allow us to solve for x. If I remember right on the homework, we need both. We need the angle measure and the value of x. So to find that angle measure, we're going to take 180. Let's subtract this 93 degrees and also this 54 degrees. And that tells us that that other angle is, so 33 degrees is one of our answers because that's the angle right here, 33 degrees.
Then you divide it by 3?
But yeah, so that 33 degrees is going to equal that 3x. So to solve this, we would divide both sides by 3. That cancels the 3 out right there, giving us 1x equals 11. So then we see that x is 11. We don't really need the one there. We'll make it a phantom one. Alright, once again, we will need to figure out what this missing angle is before we figure out what x is. So all 3 angles will add up to 180. So if we subtract these 2 angles, the 102, if I subtract that, and I subtract the 43, it will tell me the measure of that 3rd angle right there. So that is 35 degree. Alright, well let's not forget that this angle is 35 degrees, radical. So that's one of our answers. But then we need to solve for x, so we got that 35 degrees, which equals the 5x. So yeah, we would divide both sides by 5. And then we get our 1x equals 7. So x is 7, and the angle measure was 35 degrees. One angle of a triangle is 5 times the smallest angle. The other angle is 40 degrees. They didn't give us a diagram on this one, so I'm going to make our own. Now, what it looks like is not necessarily important. I mean, it could be obtuse, it could be acute. Doesn't matter. All we know is that one of the angles is 40 degrees. One of the other angles, compared to another angle, is 5 of them. So if I said the green here is x, then the purple one has to be 5 of those x's. Like this. Alright, so the equation for this is we've got that 40-degree angle. We got the 5 x's. And we got the x, that's the smallest. If I add these together, I should get 180. So that's our equation right there. Now what I can do is, let's go ahead and do that. Subtract 40 from both sides. So I'm going to solve this just like I would a regular equation. So that gives me 140 equals, I'm going to look at this as a 1x right there. So if I had 5 x's and 1 x's, I'd have 6 x's. Yeah, then we divide both sides by 6. And that tells me what x is. Now again, this doesn't give me both angles, it just gives me one of them. 23.3 repeated, well, x is degrees, that's fine. Because that's this one, 23.3 repeated degrees. So x gave us not only an angle, but I guess also a value of x. So next, we need to figure out what 5 of those x's are. So 5 times 23.3 repeating. 116.6 degrees, repeating. That means that will just be this angle right here, 116.6 degrees. 6, this one is tricky only because of the way it's worded. So it says the sum of the two angles is 37.5 degrees. We don't like mixed numbers, so I'm going to change that into a decimal. So 37.5 degrees. Now, as it turns out, that's 2 of the 3 angles. So I'm going to take 180 and subtract it to find that other one.
Oh.
Yeah. So doing the subtraction. So that third angle has to be 142.5 degrees. Bam. So yeah, we don't need to solve for that those two angles. We could divide that by 2 and figure that out. But in this case, it just wanted that third angle, which we solved for. The ratio of the angles of a triangle is 3 to 2 to 1. So again, I am going to draw a triangle on this. And we'll see what the heck happens with it. Yeah. So we're going to say that the ratio, again, is 1 to 2 to 3. And we're going to tack on x's on these. Because we're multiplying them by something, we just don't know what it is yet. Once we figure out what that is, then we can figure out what the angles are. Alright, so the equation is, we need to take all 3 of these angles, the 1x, the 2x, and the 3x. And again, if we add these, we get 180. Because all 3 angles for any triangle is 180. So if I look at these x's, how many x's do I have? 6 of them. So 6x equals 180. And when I solve this, which I'm going to do next, that is going to tell me how large that smallest angle is, 30 degrees. Now, that means that this one, for our diagram, was 30 degrees. If that is 30 degrees, then how big is 2 of them? 60 degrees. And what about 3 of them? 90 degrees. So that would be our 3 answers, 30 degrees, 60 degrees, and 90 degrees. So yeah, that ratio, it lines up, right? It'd be 90, 60, 30, which if we simplified this by dividing each of these by 30, then we would get the 3 to 2 to 1 ratio, and that checks off. One of the angles of a triangle is 1/4 the size of the largest. The other angle is 1/2 the size of the largest. What are the measures of all the angles? So again, we can draw some kind of triangle like this. I'm saying, and that's what it's saying as well, is that x, we're saying, is the largest. One of the angles is 1/4 of that, so that'd be 1/4 of an x. And then the other angle is half of the x. So that should bring us to the equation. This would be 1x. I've got 1/4 of an x, and then half of an x. If I add these, I should get 180. So combining my x's, 1 plus 1/4 plus 1/2. So I got 7/4 x equals 180. I'm going to solve this in 2 steps by multiplying both sides by 4 first, canceling out our denominator. So 7x equals 720, and dividing both sides by 7 tells me the largest angle. Well, I can keep that as an improper fraction if I want. Yeah, that's what I'm going to do. 7/27 degrees. Now the other angle, this one, is 1/4 of that. So that would be 7/27. And would divide that by 4. Or you could say multiply it by 1/4. And that would give us 720/28. So 187 in degrees. It's one of our angles. We already had this one. And the other one was to cut it in half. So that would have given us 7/27 times 1/2, which would have been 367 degrees.
Have it in decimals?
Yeah, you can use the decimals. The problem with sevenths is it has a very long decimal that goes on forever, but it repeats. So I'm using these just because, for me, the multiplication is easier with the fractions. If not, then that's fine. You can use the decimals. This one just looks a little weird, but it's another ratio with 3 different values. It's a 5 to 2/3 to 1 ratio on this. So, again, if I drew a triangle, and I would have one of these as a 5, one as a 2/3, and one as a 1. As a ratio, we'd have to multiply these by something to figure out what the actual ratio is for the actual angles, which means that I'm going to have to take each of these, 5, 2/3 of an x, and then 1 full x, and I need to add these together to get 180 degrees. So if I add these all together, all the x's, so I got 20/3 by changing 5 into 15/3 x. So I need common denominators before I add the fractions, and then 1 would be 3/3 x. So 15 plus 2 plus 3 is 20/3. And that's how many x's I have. So solving this one like we did the last one, I'm going to multiply both sides by 3, which again takes away the denominator or the fraction. So that's 540. Now to solve, I just need to divide both sides by 20. And that will tell me how big that x is. So one of them is 27 degrees. The big one, which is 5 of them, so I'm going to do 5 times 27 now. So 135 degrees, I got 27 degrees, 135 degrees. Alright, and then the final one is 2/3 of the 27, which would be 18 degrees. Now again, you can find these, all 3 of them, by just plugging it into the calculator. Later on, again, it's going to ask for what the x is and the 3 angles. So you got to find all 4 parts. One angle of a triangle is 63 degrees. The ratio of the other 2 angles is 5 to 2. What are the measures of all the angles of the triangle? Alright, so again, I'm just going to draw a random triangle like these. It tells us one of these angles is 63 degrees. Now the other 2 angles are in the ratio of 5 to 2. So I'm going to make this 5 of something and this one 2 of the same thing. Alright. So when I add these together, well actually, the sum of those 2 angles is just going to be, I'm going to take 180 and subtract the 63 action right here. So that'd be 117 degrees for just the 2 angles to split up. That means that that would equal the 5x and the 2x combined. So we're going to add those. Adding those together would give us 7x's, which would equal 117. And when I divide these, this is not going to tell me the answer to this problem. It's only going to tell me the value of x. 117 divided by 7. Alright, yeah, I guess we can make it 16.7. That's fine. Alright, so one of the angles is 5 of those x's. So I'm going to take 5 and multiply it by 16.7. And that would give me, alright, I got 83.5 degrees for the 5 x's. Of course, we already had the 63 degrees, right? So the other angle is 2 of those 16.7s.
Couldn't you just add 83.5?
So that one is 33.4 degrees.
You're going to be 1.
Now that's another thing about this is we should be able to add all these together,
1 off.
and we should get 180. Now, yes, when we do add these together, as it turns out, we will be...
100 off.
Is it only 100? Yeah. We're going to be off by 1/10, which is okay, and that happens because we rounded that decimal that, well, was pretty ugly.
When it is.
All right, good luck. Number 11.
I don't think it's the count.
Go ahead and get started.
Okay, so I'd have 15.75. Oh, that's
Okay, you got to talk while you explain it.
okay. And then you times it by 3.
Well, how'd you get 15.75?
At first I did 5 minus, not 5, 54. Saved it. Minus 180.
Well, 180 minus 54.
Yeah, that's what I meant. I'll just. Yeah, okay. And then I got 54. And I got 126. And I divided it by 8. And got 15.75. So then we'd come back up here and you'd get 47.25. And then do it again. No, times 5 and get 78.75 plus the 54, and all 3 of those together equals 180 somehow.
All right. Nice.
Did I do it right?
It's close. We just need to label them in degrees.
Oh.
Sal, I got it.
Two angles of a right triangle have the ratio of 5 to 7.
Right triangle.
What are the measures of the angles? Well, we already have this right angle right here at 90 degrees. Good luck.
Okay. So we have 90 degrees of an angle, and then we have 2 unknown, and that'll be like 5 about, and that'll be 7x. No, not x. Never mind. Okay, so ignore those. I'm not starting off good. Okay, so we take 180 degrees, and we minus 90 degrees from it, and then we have 90 degrees, and then we take 90 degrees and we divide it by 9. Sorry, my brain just, okay, by 13, yes, and then 90 divided by 13 equals, then we get about 6.9, and how's it wrong?
Let her finish.
Did I do it wrong? What did I do it wrong?
Okay, if you do this wrong,
It's 13.
I did it wrong.
5 plus 12. No.
5 plus 7 is 12. Oh. I got it wrong. Okay. 90 divided by 12, not 13. No, 13 is bad. We do 12. Okay. 5 plus 7 equals... No, wait. 5 plus 7. Yes, okay. 90 divided by 12 equals 7.5. Not that. Okay, so we have 7.5, and then you times that by 5, and you get 37.
First talking over there.
5 degrees, and so that splits right here, so 30. It won't let me write. Oh, I got it. 37.5 degrees, and then we do 7.5 times, yes, 7, and then that equals 52.5. There's not enough room to write 5 right there. You can't see that, but I can. And so that's what that is there. I did a really bad job.
That was great.
That was...
Good job.
It's just not.
So we do got the 37.5 degrees, and then this one was 52.5.
I am not good at I can't write with stylus.
We have this on a poster, well, 3 posters. But the circumference of a circle and the area of a circle is pretty important stuff. The circumference of a circle, which we show as C, that would be the diameter times the pi. So if they give you the radius, just multiply it by 2, and you would have the diameter. The area of a circle, A, is when we take the radius, multiply it by the radius, and then multiply that by pi. So with the circumference, and we wanted to find the diameter, you could. Alright, so let's look at the formula. That's the circumference equals the diameter times pi. So how would we find the diameter? We would divide both sides by pi, canceling these out. So the diameter of any circle is when you take the circumference and divide it by pi. That is how you would find the diameter. Michael loved swimming. He swam around the edge of a circular pool and found... That's what it says. What the heck? Well, he found that it took him 176 strokes to swim 1 complete time around the pool. About how many strokes will it take him to swim across the pool? Now it says to use 3.14 for pi. I'm not going to use that. I'm going to use the actual pi button for this. Okay, so what that means is if we look at a circle, something like these, it took him exactly 176 strokes to get around this circle. So yeah, that's the circumference. So if we look at this circumference, and in this case we want to figure out how far it is, or how many strokes it would take him to swim across the pool, through the pool, right? Well, then we would have to figure out what the diameter is, and we just saw that the circumference divided by pi is diameter. No, because this one is just diameter. So the circumference we saw was 176 stroke. So I'm replacing it with 176 strokes. Now to find the diameter, or how many strokes it would take him, I divide that by pi. Alright, 56.02. Yeah, I like to go in the pool. So 56.02 strokes. If you wanted to, I mean, maybe he doesn't get through that full stroke before he hits his head on the wall of the pool. So you could say 57, I suppose. 56.02 strokes. The circumference of the center circle of a soccer field, 31.416 yards. What is the radius? Oh, the circle. Alright, so this soccer field has a circumference of 31.416 yards. And as we saw on that other problem, the diameter is the circumference divided by pi. Now this is just going to give us the diameter, but if I take that 31.416 and divide it by pi, then I find that my diameter, rounded, I got 10.
Yay, I got it right.
10 yards. However, the answer is not the diameter. It wanted the radius, so I'm going to divide this by 2, because the diameter divided by 2 is the radius, which then would be 5 yards. Let's see. Find the radius of a circle with a circumference of 22 foot. So we're going to find the diameter first. And the diameter is the circumference divided by old pi. Well, if we use the circumference it gave us, which was 22 foot, I'm going to divide that by pi. All right, with this value, the diameter is that in foots. I'm just going to use 7 because it's very small values there. So we're going to say the diameter is 7 foot. If I wanted the radius, what do I got to do with this? There we go. So the radius, I'm going to take the diameter and divide it by 2, which would be, as a decimal, 3.5 in foot.
I got it right. Good for you.
Pizzas are sold according to diameter. For example, a 6-inch pizza has a diameter of 6 inches. At Francesco's Pizzeria, there are 2 pizzas. Pizza A is 12-inch, and Pizza B is an area of 450 inches squared. Which pizza are bigger? Well, they gave us different measurements, right? One is area, and one is the diameter. Now, we get to assume that these are circular, because they did say they were diameter. What is the percent of increase from the smaller pizza to the larger one? Let's look. So I'm going to start with pizza A first. Pizza A, if I wanted the area, then I would take the radius, which is 6. Because the diameter is 12.
Bless you.
So the area is 6 times 6 times pi. So what would that give us approximately right there? So the area of that 12-inch pizza is about 113.1 inches squared. Now we already know that pizza B has an area of 450 inches squared. So right away we can say that B is bigger. But then it asks us for the percent of increase from the smaller pizza to the larger pizza. So to find the percent increase, we need to find the difference between the two areas. So it's a difference of 336.9 square inches, but it wants to know how much increase it is from the smaller pizza to the larger one. So that means we need to divide that 113.1, and this will tell us the percent increase.
2.9.
So when we divide this, what we get, this is the decimal value, not the percent. So to change this into a percent, I just move the decimal twice. 297.88% increase. Bam. A farmer has 100 foot by 100 foot plot of land. He needs and must water. He has a sprinkler that waters in a cycle. The sprinkler has a reach of 50 foot. If he puts the sprinkler in the center of the plot of land, what percent of the plot will be watered? Okay, so the first thing we got up in here is this. It's really a square right there. Nice square land. So the area of that square would be 100 times 100. Now that's the whole thing. So that would be 10,000? 10,000 square footages. Next we need to figure out how much the sprinkler will cover. So it's a cycle with a radius of 50. So the area of the cycle is going to be 50 times 50 times a pi. So I'm rounding that to 7,854 feet squared. Now the question is not how much is missing or how much bigger one is. It's if he puts the sprinkler in the center of the plot, what percent of the plot will be watered? So we're going to set up a percent proportion on these out of 100. What we want out of this is the percent. The sprinkler is going to cover part of the land, so that's 7,854. And we will divide this by the total area, all of it, the whole area, 10,000. So this will come out using fish method or cross multiplication or scale factors. We get 78.54%. That is all it's going to cover. That means this farmer is missing out on over 20% of land by keeping this circular sprinkler. A bike's wheel diameter is 50 centimeters. So I'm going to draw a bike wheel something like a tease. The diameter of it is 50 centimeters. If the wheel rotates 45 times a minute, how far has the bike traveled after 30 minutes? Alright, so what we need out of this is the circumference. So the circumference is the diameter 50 times a pi, which is about what? What did you guys guess? Alright, so if that's the circumference, that's how far it would go with one rotation, but we got to figure out how many times it's gonna, how far it would go in, well, 1 minute. So it goes 45 times in 1 minute, so we're going to take that 157.1 and we need to multiply that by 45 times. This will tell us how far it would go in 1 minute.
Yeah, 7,000.
Alright, 7,069.5 centimeters in 1 minute. But this is going to happen for 30 minutes. So we are going to multiply this by 30 for 30 minutes.
Big number.
And the answer is, alright, so it looks like it's approximately 212,085 centimeters.
Oh, I forgot about that part.
Which it appears would be 20.85 meters. Not that you guys care about that, but that will do. Right there. Mary has a circular table whose diameter is 7 foot. So this is a table.
So what did they do?
Its diameter is 7 foot. She would like to put a tablecloth on it, but the packaging only gives the area, which would be weird. The tablecloth she bought says it is 110 square foot. Will it fit? Of course, we're assuming it's circular. So let's find the area of this cycle. So if the diameter is 7, then the radius is 3.5 foot. So find the area of that table. We got 3.5. That's right. Radius times a pi. 38.48. This would be square feet.
So yes, the tablecloth.
And so yes, it will definitely fit.
Got it wrong,
In fact, not only does it fit, but
It'll probably be
it may be too big, as it turns out.
They could